Hi guys, welcome to lesson 12.6, Combinations and Permutations. Our objective for today is that I can find permutations and combinations. What is a permutation? Well, it's an arrangement of objects in a specific order. That's the important part there, is the specific order. And a combination is a selection of objects without regard for order. So order does not matter for a combination. You can use counting methods to find the number of possible ways to choose an object with or without regard to order. So the first of our ways is the multiplication counting principle. And what this says is that if there are m ways to make the first selection and n ways to make the second selection, you simply multiply m times n in order to get your total number of combinations. So we have a pizza shop that offers 8 vegetable toppings and 6 meat toppings. How many different pizzas can you order with 1 meat topping and 1 vegetable topping? Well, if there's 8 veggie and 6 meat, 8 times 6 is 48 combos. In 2016, the Toyota Corolla was the world's best-selling car. There are 10 paint options and 7 interior options. If assuming all paint and interior options could be chosen together, how many possible combinations of 1 paint and 1 interior are there? 10 times 7 is 70 combos. Okay, next page. Go ahead and work on that. So we have during the Pi Day breakout, Mr. Boland's hooligan algebra students changed the combination on one of the 3-digit locks. How many possible combinations was Mr. Boland have to try to unlock it? Well, you've got 10 for the first digit, or 0 through 10, or 0 through 9, times 10 for the second digit, times 10 for the third digit is 1,000 combos. True story, I made it all the way up until like 500 and some odd before I found the one that actually unlocked the lock. Alright, letter D, you're required to have an 8-character password. How many potential passwords are there if you only use letters? And then how many potential passwords are there if you use an alphanumeric password? Alphanumeric means alphabet and numbers. Alright, so if we only use letters, well, you've got lowercase and uppercase letters, so you have 52, and it's an 8-character password, so 52 times 52 times 52 times 52, 1, 2, 3, 4 times 52 times 52 times 52 times 52, 1, 2, 3, 4, 5, 6, 7, 8. Yay, there's the magic number. All right. So when you multiply that out, you get, and it's in scientific notation, 5.34 times 10 to the 13th power. That is a lot of combinations. Now, if you add in the numeric part of it, so that's an additional 10, now you've got 62, and we can just raise this to the 8th power because it's 62 times 62 over and over again. And that gives us 2.18 times 10 to the 14th possible combinations. Now, for example, the little tweet over here off to the side, my sister's password for the Disney website, Mickey, Minnie, Goofy, Pluto. Just asked why. They said use 4 characters. That would actually be an extremely strong password. You have 22 characters in that. So you have 52, because that's alphanumeric, to the 22nd power would give you 5.65 times 10 to the 37th. So one way hackers use to try to crack passwords is literally they have a computer that will just continuously try every single possible combination of letters and numbers in order to crack the password. You would have to go through a heck of a lot of combinations. 5.65 times 10 to the 37. So that's 35 zeros at the end of this number in order to find the number of combinations that are possible using that many characters. So something actually security experts are saying, if you're going to use a passphrase instead of just a password, something like this would be very easy to remember, and it's a whole lot of characters and makes it extremely strong as a password. Okay? All right. Now, finding permutations. How many different lineups can Joe Madden create from his starting 9 players? Well, in the leadoff spot, he's got 9 possible players in the lineup that he could put in the leadoff spot. So in the second spot, he only has 8. In the third spot, he only has 7. Fourth spot only has 6. Fifth spot has 5. Sixth spot has 4. Seventh spot has 3. Eighth spot has 2. And the ninth spot has 1. So that would give us 362,880 lineups. That's a lot of different possible lineup combinations. And that's just with your starting 9. If you start throwing in the bench players, you've got a lot of different things that Joe Madden can do. And of all managers, he probably comes up with the most lineups. Now, a track has 8 lanes. In how many ways can the 8 runners be assigned lanes for the race? Well, we could do what we just did and list out 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Or we can use this, which is factorial, which means 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Now, to get to it on our calculators, you need to go to Math, PRB, and then 5. So you would actually type in your number first. So we want to know factorial of 8. So you would type in 8, go to the math button, probability, factorial, and hit enter. And you get 40,320. All right. So now permutation notation. Permutation is representing the number of permutations, or how the number of choices objects arranged are at a time. So we have total number, how many we're doing at once. So in this example, we had 8 possible choices that we're going to put into a group of 2. And our formula for that is n factorial over n minus r factorial. All right, so we have a band that has 7 new songs and wants to put 5 of them on a demo track or demo CD. How many arrangements of 5 songs are possible? So we have 7 new songs. 7 is our total. So we have the permutation of 7 arranged 5 at a time. So that's going to be 7 factorial over 7 minus 2 factorial. When you do that math, you get 5,040 over 2, which is 2520. Okay. Smashing Pumpkins, Melancholy and the Infinite Sadness. First CD I ever bought. Awesome album. All right. So you have 6 students in a classroom with 8 desks. How many possible seating arrangements are there in that classroom? Well, we have 8 desks total, and we're only filling 6 of them at a time. So it'll be 8 factorial over 6 minus, 8 minus 6 factorial. Okay. And that is going to be 40,320 over 2, which gives us 20,160 different seating charts. Now, I know what you're thinking. Mr. Boland, this is a real hassle to memorize this formula. How on earth can I ever do it? Well, I will show you a shortcut. Actually, we'll go back to the last problem for that. So you might have noticed when we went to that math button that you go to PRB, oh look, NPR and NCR. Huh. So if we use NPR, not National Public Radio, but it is a permutation, so 8 going into 6 ways, 20,160 combinations, which is exactly what we came up with our calculation. Okay, so that math function will do the permutation notation for you. It'll do the work for you. Now, letter C is just kind of an oddball question. You got 8 council members in the cast of Hairspray Jr. How many different ways can they introduce themselves for their roll call? So we've got 8 council members, and there's going to be 8 of them. So we can use permutation for this. So we have permutation notation of 8 being chosen 8 ways. Well, that's 8 factorial over 8 minus 8 factorial. Well, wait a minute. 8 minus 8 is 0. What's 0 factorial? 0 factorial is 1. So it'll be still 40,320 combinations. So even though this really would be multiplication counting principle, because you have, this would just be the, what we did before by using factorials, where we're just arranging them permutations at a time, but we're just using all of the spots. All of the Hairspray members or all the council members are going to be used. There's going to be no leftovers. Okay, so this is the total number that you would have. Next week, tickets will be on sale. The show is 18, 19, and 20th of May. Make sure you come and see the show. It's going to be awesome. We got a lot of our students in it. A lot of your classmates, some of you listening to this are in it, and you're probably cringing that I'm telling people to watch the show right now. All right, so problem 4, using combination notation. So this is when the order of the choices doesn't matter. All right, so we're choosing 20 people for jury duty. How many different 12-person juries can be chosen? Well, it doesn't matter whether you're juror 1 or juror 12. You just need to do 12 people. So we've got the combination of 20 total jurors in the pool. We're only picking 12 of them. So that's 20 factorial over 12 factorial times 20 minus 12 factorial. Again, Mr. Boland, this seems like a lot of work to memorize. Well, that's all right. We got technology to help us. So 20 probability of combinations, and we're going 12 at a time. So that gives us 125,970 combinations. So with those 12 people, you can come up with that many different juries. Okay. Now, last 2 problems. How many different ways can you choose 3 types of flowers for a bouquet from 15 types of flowers to be possible? We have a combination of 15, 3, so that's 15 factorial over 3 factorial times 15 minus 3 factorial. And that's going to give us 455 bouquets. Okay. All right, 10 employees are eligible for 4 promotions. How many different ways can the promotions be earned if the order is not important? All right, so we've got 10 C4. So that's 10 factorial over 4 factorial times 10 minus 4 factorial. That is 210 different combinations. That's the notes for today. Make sure you fill out your level of understanding, write down any questions or concerns you may have from this lesson, and then do make sure you write your summary of how do you find combinations and how do you find permutations. That's all for tonight. Have a great night.